manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
So welcome to today's podcast. We're actually here in the studio in Burton Latimer, but we're going to be talking about an event that we were at yesterday, which was the Yamazaki Mazak Emo Encore event. It was a very well attended event. In fact, I think on the first day they had over 200 people through the door. The following day, which we were there yesterday as well, I think had over 200 as well. And I know the event's still on today, I believe, isn't it? Mm-hmm. So anyway, I'm joined by Gio, Joe and Lyndsey, and we're going to be talking about some of the highlights from the event. So if you didn't manage to get there, some of the machines that were, some of them actually making their UK debuts at the event, some fabulous technology, and we're going to touch on most of them now. And I'm sure these are machines you'll be able to still go back to Worcester and see. Even after the Emo Encore event. And I think probably the best way, guys, is to pick each machine, and we'll probably start with the one I spent most time looking at, which was the CV5, the new CV5 5-axis. We did a video, in fact, put that onto YouTube yesterday, and I think overnight that was watched about 1,000 times. And for those of you that are into your digital media, you'll know that retention of watching videos is probably one of the most crucial aspects or statistics. And that video had a 75% retention, which was,
and it was you as well.
Yeah,
so quite remarkable.
But I have to put it down to some of the handiwork of the cameraman as well, which was Gio, because we were shooting it on our mobile rig. But it was good because, it was quite a fast-paced video, but we saw the machine cutting. And I think generally people are very interested in Mazak's technology, especially when they launch what they class as an entry-level 5-axis machine, what this is. Gio, you shot that video. Did you listen to what I was talking about on it?
Yeah, it was a good video. It was well shot.
You have a problem if you didn't.
I think the machine it's been designed to fill a gap at Mazak, hasn't it? And I think it really is going to be a massive game changer in regards to the capabilities of the machine and the price in which you can buy the machine for. This is a full 5th axis simultaneous. There's no options. There's no 3+2, 4+1. It comes as standard full 5th axis simultaneous. You've got a Y-axis configuration which embeds itself into the back of the machine to create a larger internal working envelope. You've got a 500mm bed. You've got a choice of spindles, actually, in regards to speeds. You've got 3 different choices on swarf management systems and through coolant. But it's absolutely everything that you could possibly want in a 5th axis machine. That's manufactured at the UK in the UK at Worcester at an unbelievable price. I was really shocked.
Can I have one? Well done, Gio.
Yeah, sold.
Yeah. For me, it's difficult. Mazak almost not embarrassed. That wouldn't be the right term, but they're like the only thing entry level is the price. It's not they haven't taken all the costs out of a machine and made a commodity machine. It's still the build. It's still the quality you'd expect from a Worcester built machine. Well, a Mazak machine in general. It's just the price, isn't it? It's just astonishing, really.
I think that's what came up from... I was actually reading some of the comments at the bottom of your video, and as we do, and people are saying, talking about it, and the price is the main thing that people are questioning. They're like, well, it's going to be this much. It's going to, if you're bringing this to the market, it's got to be this and this and this. And actually, you're pleasantly surprised by. We won't talk price here, but it's a good price.
Yeah, we don't know the exact price anyway. But what we do know is that the machine, the prices of other machines, which they're kind of benchmarking this price at, which will take them into situations where they're competing with the masses. And that's really what the business that they're trying to win from this. There is no secret in the fact that the UK market, if you're looking for a 5-axis machine and you put it out there to the machine tool industry, you will have, a dozen or even more, probably 20 manufacturers or suppliers, distributors coming to you with a possible option. Now, previously, some of those call them competitions to sell, Mazak may have not been involved in with some of their, call it their superior high performance machines, but now they will. And will they win them? Well, they've got as good a chance of any. And I think when you look at the capabilities of the machines, some of the things that Mark Hall spoke to me about, which is in this video and other videos that I did with Mark, is things like how they configured it. The X-axis on the bridge, the Y-axis, as Gio said, is actually on the base of the machine as opposed to on a RAM. And they've got this thing called axis stacking. Do you know what that is?
I'll let you explain it.
Okay, so every axis on a machine, a lot of machine tool manufacturers tend to put one axis on top of another, like building blocks. And of course, that then means you've got more, I suppose, what's the best way to describe it?
More chance for error, isn't there?
Yeah, and you've got more
chance for error.
Chance for error. Whereas if you spread the axes around on the machine and where the mechanics of those axes work, you've got less chance for error. And that's one of the things that Mazak pride themselves on this machine. I think how they've been able to hit the sweet spot on the money side, it comes down to the fact they're going to build them in volume. The options are good, but they're limited in the sense that I think there's 3 or 4 spindles.
Yeah, 3 spindles, 3 coolant options, but all good. That's all you probably need in that marketplace.
Yeah, and a few tool changes, so they'll be readily available.
Well, they're available with immediate delivery.
Yeah, and they're very small in their size as a result of how that y-axis is configured as well.
Yeah, it has to for a 500 machine. I'm yet to see a smaller footprint.
And that table's supported both sides as well. So you know on your trunnion, which gives you better stability as well. So that's the CV5 500. Definitely worth going to Mazak to have a look. Second machine we've got on the list here is the Integrex, the hybrid machine. Gio, you did a few pieces on this, didn't you? And the gear cutting capabilities of it.
Yeah, so this machine has been developed from Mazak, from the Integrex, the standard Integrex, if you like. Now, it's been redeveloped and redesigned from the ground up for a few reasons. There's a huge demand for gears at the minute due to the electrification of cars, the aerospace industry, the production of more complex gears and the reduction in weight. So this has driven the demand to create a new Integrex machine that is predominantly to manufacture gears, but to also manufacture the turning and the milling of the part complete in one, which the Integrex machines are renowned for. The programming of it has been simplified, so they've got cycles. It's kind of conversational, so effectively
like the control. Yeah,
so you haven't got to have a very skilled. You imagine kind of create some of these complex gears, power skiving, the synchronization of the C-axis, tilting B-axis. Imagine trying to program that manually. And what they've done now, they've put cycles in there. It's made it conversational. So effectively, an operator can read from the drawing, they can put the pitch, the diameter of the part, so on and so forth, the length, and it's as simple as that. What they're selling it on in regards to USPs is obviously that it's all done in one operation. You haven't got to go and take a component to a dedicated gear cutting machine. It can all be done on that one machine. But the speed of the production of gears is something else. They're really saying that it's extremely fast, extremely accurate, and it also gets inspected on the machine. So they worked in collaboration with Renishaw to inspect the gears on the machine, which is also extremely important, because if you're taking the gear off of machines, checking it on the CMM, and it was slightly out of tolerance, to rework a gear such as that is pretty much impossible.
How do you rediscover the position of it?
Exactly that.
I don't believe you can, unless you've got some sort of slot as a deck. Even then you couldn't. I don't believe you could.
Very, very difficult because of that synchronization.
Obviously the Integrex, we'll go into the next Integrex in a minute. That's a new machine. So the AG, what's been added to that hybrid machine to make it different from the new Integrex?
So the features are, in regards to the gear cutting features, are all of the linear kind of elements which give you the accuracy, the synchronization between the C-axis and the B-axis. There's millions of increments per degree. So it's being synchronized to that nth degree to be able to produce the gears that accurately. Power skiving, for example, has been around for hundreds of years, but they've never had the right technology to be able to use that cutting tool or to produce gears that accurately with. So this machine is really the Integrex. But so if I turn it round on its head, you could still manufacture gears on an Integrex, but you couldn't manufacture them as accurately and as fast as you could on this hybrid Integrex.
Up to 658 mil as well, which is quite big for a relatively small machine.
Yeah, and it still gives you all that flexibility of being able to do standard components, with milled and turned parts. So if you were an end user that maybe were looking to get into gear manufacturing, and you could still make your normal subcontract parts, but you could also take on new work as well. So
like you say, very conversation. It's almost like an iPad, isn't it? That you've got your smooth gear cutting, your smooth gear skiving.
Simplification of programming, really. It's de-skilled it. Tremendously.
What do you think of that backup button? That's clever, isn't it?
It's very, it's kind of a get out of jail button in a way. So
I could have done that 20 years ago.
What it is if you were actually in cut when you were kind of power skiving, how closely it needs to be synchronized, it's pretty much impossible to re-pick up that cut exactly where it was. But with this button, it kind of takes it out of cut. And if you wanted to go back into cut, it can put it back in exactly the position that it was in.
We were actually at Star the other day, not at Star, but talking about a Star, and I think they were doing that now with threading. And you've got to then find where that thread is and go back and find it and then recut. And they're talking similar technologies.
Yeah, that's the same also as the I think it's the UAD head that Courier supply on a milling machine. They always say that when the head is a bit like a B-axis actually. When the B-axis moves to an angle and then drills a hole, reams a hole, bores a hole, whatever it might be, when you go away and then you try and pick up that same position again, you'll never cut the same.
Yeah.
You'll never do it, but that is as close as you can get to finite accuracy.
And the things people forget, there's a lot of certifications around gears that many manufacturers won't have, and that is something Mazak will have. So just because you can make a gear doesn't mean you can have it signed off, whereas with the Mazak machine you can.
Yeah, I think there's going to be a lot more of gear manufacturing in the future with the electrification, electric gearboxes, etc. So yeah, good machine.
What about the Optiplex, Lyndsey? You liked the giveaway on that one, didn't you?
The Optiplex.
That's the laser.
Oh, the laser one. Yes. Yeah. Oh, there was a great little giveaway there that you wanted. It was the sleigh, wasn't it?
Yes,
they were.
The Santa and the.
I was talking about the machine. They had a little Santa, and you could interlock this sheet metal to create like a 3-dimensional form of a Santa on it. Well, a sleigh and the horses, the reindeers. It was really good. But I was fascinated to see that they had this like scanning system, and you could scan and tell the machine exactly the thickness of the metal, and I was fascinated to think that you can cut with a laser 35mm.
Yeah, well, I saw the scan. I didn't quite know what it was doing, but basically it was like a barcode. It was zapping a barcode.
Zap a barcode, just like you do anything, and then suddenly that
so what does that barcode knows the material from that?
Exactly,
and
then
not just the material. There's the whole program.
The whole program, and then what it does, it then tells the machine, and then almost, if the one for a better word, calibrates the machine to fit then what it is then, the material it is then machining.
That's exactly,
so it changes the strength of the laser, everything. Not the I don't know how technical that is, but
how's that information got in there?
Well, it has to be there initially. They demonstrated an iPad, but I imagine in the real world that's going to be an engineering drawing with some sort of code, barcode, QR code type scenario. You're literally scanning it. That's telling you anything you want to know, isn't it? Is available on that. So they were demonstrating different material thicknesses, that how it was nested. The components were nested. And that bit's quite straightforward, really. The clever bit is the nozzle conditions are different for each material, for each job, like Lyndsey says. So yeah, really clever. And that's it's the third edition. It's got the latest control, and that's unique.
Is that automation? Is that the level of automation? Where's that material coming from?
It's like software automation. I guess arguably they didn't at Mazak, but arguably you could have a stack of material somewhere and a robot pick it up and pull it in and take all the humans out of it. Obviously at the show they didn't have that.
But yeah, I'm confused. So you scan in this barcode, and that is then giving you what information?
It changed the job. So if you imagine a scenario, we've got a plate of material like they did at the show, and there's approximately 20 jobs. Yeah. You selected it and scanned it, the machine would stop and it would make that part.
Right. Okay. And it would adjust everything within the machine.
Correct, yeah.
In order to
and calibrate the whole machine so it knows that part.
Yeah, it's not just cutting a different shape or whatever. It is physically changing the characteristics of the machine.
Was that one of the most was that really what they were showing there? Was there anything else that was a highlight on
the control? The control, the Preview G control. It's very familiar with the metal removal, the lathes and the turning machines, 5-axis machines. It's very, very similar, very conversational, easy to use.
Okay, let's move on to the artificial intelligence, because that was quite an interesting one. It's still the name says it all, really. But how are Mazak now, challenging What's that?
Gio's just pointed at me because I explained it earlier. Went, well, you've done that better than me.
Okay, well, maybe there's your opportunity then, because I didn't get too involved in the AI yesterday, so I'd like to know.
So basically what Mazak are talking about, and we didn't go in too much depth with AI, but they talk about a digital twin. So if you can imagine the physical machine and then a digital version of that machine. And what that happens is, with a particular process, what will happen is with that digital version, it will learn from what it's previously done. So that digital version will learn from that and then reprogram, say, your next job, similar or different, to improve that process. So if the machine knows it can get from A to B in a faster time and it recognizes a previous process, it will make improvements to the physical
Will
machine.
it do it without you giving it the authority to do it? Is that the whole idea? You're almost letting the machine make the decisions.
I think you've got override control ultimately.
Yeah.
I think that.
But what's the point in having it if you don't let it practice?
I think it's teaching itself, isn't it? So it's giving you the option, or you can use it, or you don't use it.
It's up to you. Can I give an example? Because when we went to EMO, we met a lovely gentleman from the Esprit stand, and when he talked about AI, imagine two robots and one will talk to the other, and he gave us an example of one speaking to the other, and within a minute they had learnt so much from each other. This is how quick, like our brains don't even think on this level.
You speak for yourself.
Okay, sorry, I forgot that one before. But within a minute they were speaking in their own language. So they were speaking all different languages by 45 seconds, and then by 1 minute they were talking in a totally different language and learned more than probably what we learn over our lifetime.
And they had to shut it down, didn't they?
Yes,
because it just got too intelligent.
I mean, that
So
conversation.
I found out at
level.
school I was asked to leave early because I was too intelligent. And
Everyone's
making
gonna
everyone
switch.
else look bad.
Everyone's going to switch this podcast on now.
Is
Get
that
off
why-
now because they don't believe a word we're
Is that why
saying.
you didn't get any qualifications then? Is it? Is that your
I've probably got
excuse?
more than your genuine ones. But yeah, if we look at the AI, you got the three pillars, as I would call them. You've got the AI, which Lyndsey's gone into, digital twin and automation. So AI, they're moving towards drag and drop programming. People have talked about it for many years. Is it possible? I think Mazak are pretty damn close, to be honest with you. They demonstrated an unknown part to the system. And they say, using Mazatrol, it would take 45 minutes, I think. And I thought that was impressive. But
this was to program
Don't
it,
give it
Joe.
away.
This was to
Don't
program
okay,
it.
how long do you think to program it?
We're not allowed to say.
Yeah, we'll say.
Can we say?
We'll say. Use an AI. We'll just see how many people watch Orphan Chips and this.
Yeah,
'Cause we're
that's
going to give the
fine.
answer away.
Yeah, we're gonna
But
give
yeah,
the answer.
I think 46 minutes, a mill turn part, drilled tap soles, internal grooves, lots
Maybe
of
it's
detail.
reduced it by 15%, half an hour.
What do you reckon?
Yeah, it's going to be just a matter of minutes, isn't it? Couple of minutes.
I don't know. I'm looking at you, Vic, as you know. But
I
yeah. 2 minutes 40.
Wow.
Yeah.
Wow.
2 minutes 40.
So, but what are they doing? They're getting a model and just sticking it on the
Well,
control.
well, if you think about it logically, you need a solid model. All that information's in the model. It's all sat there waiting for you.
So
All,
they just
all
drag
AI
that
is
onto
doing.
the control, and it does it, and it's doing everything else.
Correct, yeah, and it will give you recommendations. So if you want a 12 mil slot, you've got a 10 mil M mil.
Yeah.
It can either be intelligent enough to think, no, it's too small and it's got to open up, or it'll also advise you. In an ideal world, you'd change the M mil here because quite obviously, it's not the ideal conditions.
Yeah.
So there's that digital twin. It's basically you're mirroring what's on the machine tool in an office environment. And it's easy to say I've got a machine on the screen. Probably everybody does that now, don't they? Certainly the CAM companies. But this is actually a digital twin. Everything from the kinematics down to everything about the machine. Because every machine tool it's built is slightly different, even though the badge is the same. They're all very slightly different, as we know.
That's
But
what always
it's-
amazes me about these software and CAM companies when they say, what machine have you got? Oh, a Makino, blah, blah, blah. And they pull out all the
from
kinematics.
the cloud, from the cloud.
I mean, it must, who
there's
does all of that?
Yeah.
It must take an infinite amount of time for each different
Gio,
machine.
you said something about vibration. If the machine vibrates, it will then work.
I believe that the
Smooth AI spindle.
Yeah, it also monitors the machine tool as well. The axis, the x-axis, y-axis.
compensate to make
it can kind of even preventive. I can't even
Preventative.
say it. That's the one, Joe. Maintenance. So yeah, it's intelligent, isn't it? Really. I mean, the conversation we did have at Emo with Esprit was mind blowing, really, and he couldn't stress enough how powerful this is and what a game changer it is going to be.
But we think it's the future. And, I started here, 3 and a bit years ago, and we started talking about automation. And now you're physically seeing, within 3 years, automation within the machine shops that we're visiting.
Well,
so we're talking about it now, imagine.
Of Smooth AI. The third one is automation, where you actually control the robot off the machine tool. People are scared about automation. How do I program this robot? How do I do this? How do I do that? Well, Smooth AI, the third pillar, is automation. So you're able to use a conversational program that you'll recognise, but to influence the robot.
You know what I loved about it, with all of it? Well, smart brings it all together, doesn't it? And I think that's probably the next subject. But what I love about it is it's like some of these really complex subjects that some people, it's hard sometimes to get your head around it. I mean, when Industry 4.0 got introduced to us all, we weren't really sure what it was, what it entailed. It was a word that people were using, but didn't really fully understand that word. But Mazak seemed to simplify things and make things easy to understand, but they also work.
Yeah,
that's through design, isn't it?
The brilliance in it is making it easy, because you don't want to frighten people off before. You need to show them that they can adopt this quickly and easily and get a return on it. I know we've got smart there, but I want to talk about this Integrex. I'd sort of focus on the machines, really, the machine technology, the Integrex with the automation cell there. I think it's called the Flex Cell.
Flex Cell something? What was the third word? Auto Flex Cell, maybe?
I think it's the Auto Flex
Incredible,
Cell.
yeah.
Yeah, brilliant. Absolutely brilliant. With a Fanuc robot loading the Integrex machine. And what was fascinating to me about this is the fact that how they have changed the Integrex machines now in order to be able to be configured with automation and keep their ergonomics. Now,
but also with human intervention as well.
Yes,
they've made massive improvements.
So the problem, they've taken problems and solved the problems, and the problems were with the Integrex, if you can call them problems, is that the operator could stand in front of the Integrex, and to his left was the tool magazine, in front of him was the chuck, and to the right was the control. Everything accessible within an arm's length, obviously depending how long. Well, you've got monkey arms, so it would be okay for you. But
who?
For certainly not
for
me.
Gio and Joe. Okay, yeah. Just checking.
Joe's got monkey legs, but yeah. So to reach all of those areas was very easy. Now, of course, if you introduce a robot and put a robot in front of the chuck to load the chuck, to load the tool magazine, it gets in the way. It gets in the way, and then how does the operator then, the interface with the machine and the operator becomes complicated. So what Mazak have done with the new Integrex, if they've in fact increased the working envelope, but made the footprint smaller on the machines. They put the tool magazine around the back, and you might think, okay, well, that means we're going to walk around the back to load the tools. But actually, no, you haven't, because they've got an access point at the front where you load the tools through, and they get put into the back of the magazine. But you can also do that with a robot. So they've improved that as well. And the footprint of the machine is far smaller, and they've made them more rigid. And with the elements of the control that you're talking about, with the automation, everything is done through the control. So whether you buy an Integrex now and use it with the man to load it, unload it, you've still got the same ease of use as you had before. If you want to add a robot to it, that's as easy as well, and it won't get in the way.
They've listened to their customers. They've seen, like you said, not a problem, but potential for problems, future-proofing, we always say that, and they've improved on it, and massively, and they're doing a great job at it.
Essentially, what we have is people talk about automation. In fact, I heard it from somebody yesterday. So we don't do volume, so we can't embrace automation. And how often do we hear that? Whereas this cell, there was 3 different components, and the robot was handling everything. So it would load one component, it would ghost machine it, and then the robot would remove that part. It would take the chuck jaws out, put in the new chuck jaws, change the tools because it was a large side and face mill, 400 mil, too big for the carousel. Then it would machine another part. And basically where I'm going with this, 3 different components with 3 different chuck diameters, different tooling, and there's no one there. Just the robot.
Actually, Mark was telling us about the tool carousel and saying, I don't know all of the Mazak figures, but how many tools you can have on the machine. And there's people now demanding hundreds and hundreds. And he's saying, so basically using automation, you can get a tool, you can store all your tools somewhere else in the facility and then bring them over as and when, and then the robot's just going to load all those tools as well.
Why buy an Integrex with a 250 station tool changer when you don't need it? Because it will cost you more money. Okay, but in the future you might want 250 tools. Okay, well, have a tool carousel that you can store them in and load them through a robot.
Automate them.
You could have a tooling library of 100,000 tools, couldn't you? And in theory, if you've got these machines lined up, you only need one tool per machine, don't you? Sorry, you need one per machine, but in that scenario, you don't.
I think the key point for me is what Joe's just mentioned, really. It's the automation of setups. That's the first time we've really seen that on an Integrex. You've seen an Integrex being automated to automate components predominantly for higher volume work, but to actually automate setups, different tools, this is the first time that I've seen it being done so successfully. And nothing's been compromised either. You haven't lost out on anything.
There's no room for error as well. I mean, how many times hasn't... You would hazard a guess that with the sophistication of the machines these days, if there's an issue in a machine shop on a machine like that, it could pretty much probably down to the operator and how they've set it, whether they've used an incorrect tool, put the wrong tool in. This system is gonna stop that from happening.
I was pushing Greg Cox yesterday on it. He's a great guy, Greg, and I said, but how about you could put the jaws in? They're never in exactly the same. You got to bore them out. He said, well, how do you do that? He said, we put it in your program, just bores it out. I said, but what happens if it's so far out it breaks your boring bar? He said, well, that'll never happen, but if you're that scared, just probe it first. And so it's like they've got an answer.
There's an answer
for everything, really. In theory, they showed 3 components. If you had tracks and things, that could be, providing you'd set them up previously, that could be 100 one-offs in theory, different jobs, as long as they're known jobs from the machine.
Is this going to be a game changer? Are we going to see in this solution?
But the money is automating low volumes. If you go to a machine shop and they're automating low volumes, there's always a nice car at the front.
Yeah, my only sort of trying to find the negative points, if there were any, was the fact that would it take you a long time to set all that up to get it in place? If you've only got low volumes, you've got to program it to pick up those jaws.
Artificial intelligence.
You've still got to put those jaws in the cell. You've still got to put that chuck in the cell.
You've got to do it anywhere, though.
I know, but so how much time are you going to save by doing this, or is it not just
the way robot works? You don't program the robot. It will know roughly where the jaws are, and you just teach it. So. It's certainly with the new automation element, the robo assist and all the rest of it within Smooth AI. That's not a big job at all. Of course you've got to build all the places to store this, but if you're doing automation, you've got to do it anyway. But I do take your point, yeah.
And also yesterday, I mean, we've almost been going for half an hour now, guys. But so a few of the other machines that were on show, they had twin spindle lathes being fed by robots as well, didn't they? They had additive manufacturing. They're huge horizontal machining centres. Their IAWC 300 small pallet machine. It was. Sometimes you see people putting on events and you think, is it worth going to that one? What am I going to see that's new? What's different? What's changed? But I did really feel that there was a real buzz around in that place over the last couple of days, just based on the fact that there was some real new stuff coming through, isn't there?
Well, 800 registered. I know you said the numbers early on, but day one there's over 300, and day two there was close to 300. Really? So 800, and today's the busy day. So there's going to be over 800 people at a 3-day open house. Pretty much unprecedented.
It felt like a show at Mac. That's what it felt like. And, when people go to Mac, they go to visit multiple OEMs and everyone. But you just think, wow, yesterday it was full. But on the other hand, they've got that many debuts, UK premieres. They were showing people what people wanted to see.
People got value.
Yeah,
they did. And their factory tour, they've got obviously a lot of the machines are built there. Certainly with the new one, the CV500 being built there, it was great to be able to walk around and see UK manufacturing as it is, and booming really. They've had a tremendous year this year off of the back of their innovation and a good solid customer base.
Yeah, that'll be the future of the factory, the CV500 for sure.
I think I agree with you. So there you have it. Yeah, so you can go to Mazak yourself. They are based in Worcester, just off the M5, and you can see all of these machines that we've been talking about and more. But their event, the EMO Encore, is biannually, but they do tend to have open houses throughout the year as well, so you can keep keep an eye on those on the MTD CNC website. Thanks a lot, guys. We'll
Cheers,
catch you next
Thank
time.
Cheers.